Okay, so question number 2 is to draw the Lewis structure for sulfur trioxide molecule. Be sure to include all resonance structures that satisfy the octet rule. Okay, so sulfur trioxide, if we were to draw its Lewis structure, we first need to find out the total number of valence electrons for this molecule. Okay, so sulfur has 6 valence electrons, and oxygen also has 6, but since there are 3 oxygen atoms, we multiply this by 3. So in total, this gives us 24 valence electrons. Okay, so now let's try to draw out a skeletal structure for this molecule. Sulfur will be our central atom since it is less electronegative than oxygen. And then we can draw 3 bonds to our oxygens, and we'll see what happens if we draw in all of our lone pairs. Okay, so if I count out how many electrons I have in this structure, where each bond contains 2 bonding electrons, then you'll see that I already have my 24. But my sulfur doesn't have a full octet yet, so I'm just going to bring a pair of electrons down to form a double bond, like so, and we get the following structure. But we'll also take into account that my oxygens will have a negative charge if I were to calculate the formal charge of these atoms. So for both of these, I'm just going to bring these electrons down to again form double bonds. And a pair of electrons will be gone to give us the following structure. Okay, so now if I double check and if I were to calculate the formal charge of all of my atoms, I can use the equation for formal charge, which is the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So first let's do it for all of the oxygens. Oxygen has 6 valence electrons, and there are 4 non-bonding electrons on each oxygen atom. And since each of them have a double bond, they contain 4 bonding electrons in total, which we divide by 2 to get a formal charge of 0. So now let's do the same thing for our sulfur. Sulfur has 6 valence electrons, and there are 0 non-bonding electrons, which are 0 lone pairs. And there are 6 bonds to sulfur, so we have 12 bonding electrons divided by 2. So this also shows sulfur having a 0 formal charge. So since all of the atoms have a formal charge of 0, then this is the preferred Lewis structure for SO3. Okay, so the junior tutor said that the Lewis structure for sulfur trioxide is the following. As observed, the Lewis structure follows the expanded octet rule, where the total valence electrons of the compound is 24. Since SO3 follows the expanded octet rule, in order to draw the resonance structures that follow the octet rule, we would use SO3 2-. Okay, so they showed how you could also have SO3 2-. If you were to gain an extra 2 electrons, then we can draw resonance structures that follow the octet rule. So this solution is correct.